Hey, hello, welcome to the show. It's me, John Park. It's time for John Park's Workshop. Thanks for stopping by. We have our chat over in Discord. If you're wondering where that's at, check it out right here in Discord. It's at adafruit.it/discord, and we're in the live broadcast chat channel. And I am very pleased with myself because I've been meaning to, for ages, to set up some camera layers that do this sort of thing, so that I'm not like stuck hiding behind the windows I bring up. So now we can see me side by side with much bigger windows for at least a few of these things. Also, one of the reasons I did this, or one of the things that enabled this, is a friend of mine showed me a trick that Google Chrome has in it that they debuted somewhere around the year 2012 that I just found out about, that makes this really helpful just in the context of broadcasting with Wirecast. And that is, in a Chrome browser, you can turn a page into essentially a Chrome app by going to the three dots, and there's like a save shortcut as, and you can open it in its own window. So now I have separate apps that were normally just tabs or windows in Chrome, which made it way harder to do this sort of thing and then come back next week and have it all still work. So I think this is how Chromebooks work. They just save Chrome pages as a separate window thing. So go check that out. If you're interested, I'll show you how that works sometime. But it has made my life easier. It also means I have distinct icons in my dock down at the bottom, taskbar or dock, for these things, and it's not just like one instance of Chrome and a bazillion tabs that you can't find. You can alt tab through them and so on. Super pleased about this. So yeah, interesting, right? I thought it was a revelation. Maybe I'll show you how it works. Yeah, check this out. So here's a browser, and right now this is just a regular old browser. Can you see this? Let me see if you can see that. Will it show a pop-up window? Oh, it won't. No, it's not showing the pop-up. Okay, but you can see I clicked on those three dots in the upper right corner, and then you go to More Tools, Create Shortcut, and then a Create Shortcut window pops open, and you can choose a checkbox for Open as Window. That'll turn it into this kind of Chrome app. So there you go. That's my tip that I'm super happy about. Let's talk about jobs. We've got a job board here at Adafruit. If you go to jobs.adafruit.com, you can take a look at positions that are open. It's free to use, free to go look for a job. It's also free to post if you're looking to hire someone, and it's free to post your resume. So there's some new ones up here since last week. There's a hardware engineer position, part-time, with a potential for full-time CTO. They got big plans at Bright Smart Rings in Chicago. Also a systems administrator at Pratt Institute in Brooklyn, New York. So go check those out, see if they are for you. That's jobs.adafruit.com. Let's see, what else? On Tuesdays, I've got this show right here, which is JP's product pick of the week. I just had it 2 days ago, Tuesday. And on it, I like to show a new product pick or an oldie but goodie and give you a huge discount on it if you buy it during the show, 50% off in this case. And I do about a 15-minute show and tell of it, show you how it works, pick around some of the hardware, software, circuit, how you put it together, code it, if it's that sort of thing. This week we had one of my favorites, which is this terminal block Featherwing. So here's a little 1-minute recap. Check it out. My product pick of the week is the terminal block Featherwing. This is fantastic. This breaks out all the pins of your Feather plus some extras onto screw terminals so you can add wiring and get a really nice and secure connection. Every one of those pins that you might be tempted to use on a breadboard and have wires fall out on you and then it's sad, instead this is happy because you get these nice secure terminal blocks that you can screw down wires. I wanted to use one of these, right? How are you going to plug one of these into your Feather project? Well, this is kind of a nice way to do it. So I've got the NeoPixels plugged in. I've got the analog throttle plugged in. And then I also have some controls here with the D-pad, just lighting different numbers of LEDs on here depending on which buttons I press. It is the terminal block Featherwing. Yes, it is indeed. Over in the chat, I saw that DJ Devon 3 said their Arduino R-through screw shield is on the way. Yay! Thank you so much. That's the one that Todd and our friend Brian Jepson and I designed many years ago. And we get a tiny little piece of that action when you buy one of those. So thank you. It's also a very cool board. You know which one I'm talking about? I showed this during the show. Where's one? Here's one. Here's one with stuff plugged into it. Super useful. Also, same idea. Terminals, plugs into your Arduino, in this case, Uno-shaped Arduino. Gives you lots of terminals to plug your stuff into. All right, let's see. Next up, why don't we do a CircuitPython parsec? I have I think a really cool and useful one today. I like to think they all are, but this one I'm particularly happy about because it fits into the project I'm working on. So check it out. All right, here we go. Let me get set up. All right. For the CircuitPython parsec today, I wanted to talk about sorting lists. So sometimes you have lists of things. In many cases, it will be a SD card directory, which leads into a project I'm working on, where you can list the contents of something, and then you want to do things like sort it into a alphabetical list or other criteria. So how do you do this? If you look here, I've got this OS library installed. So importing, rather. Import the OS library. And then what I'm doing here is creating a list called fruits. And then down at the bottom, I'm just skipping ahead to printing that list out. So if I hit save on this, you'll see right here on my Pi badge, I've got the list printed out in the order that I typed it into that list. If I want to sort that alphabetically, all I do is take that list, and I'm essentially going to rebuild the list, but this time in alphabetical order. So fruits.sort. That's all it takes. When I save this, you can see same list is printed, but after being created, it's now being sorted, and it's alphabetical. You can also use sorts, whoops. You can also use the same command, fruits.sort, and then reverse equals true, and that's gonna, you guessed it, reverse that list. So now I can print them out reverse alphabetical order. And then you can also do some really sophisticated things by creating functions that get called by the sort. So this is going to sort it alphabetically, and it's going to sort by the length of each element. So if you look here, I've got this function called length sort element, return the length of the element. So when I hit save on this, now they are sorted by the smallest to the longest word in there. And you can do things like reverse that and add on to this. But this is a really simple way to take lists and sort them so they are more useful to you. And that is your CircuitPython parsec. All right, hope that's a useful tip for people. And let me bring my Discord up so I can see what's going on in there. And hey, over in the YouTube chat, hello, I see you. Gary T, you almost missed it. Well, I'm glad you're here. Thanks for stopping by. Liz says, Split City DIY, hello, Liz says, I've been doing a lot with lists lately. Intense how much you can do. Indeed. All right, so let's see, next thing we're going to do, I wanted to do a gear report. So this is actually a thrift store report, a thrift shop report. So let me change over to a bench cam view of the world and bring up a little view there, and I'm going to head over here. So I was over at the local thrift store. Let me focus this a little better. Actually, I have to change it when I flip this gizmo up. And usually I don't pay too much attention to stereo equipment. A lot of it is like big CD changers and things that I just don't have space or too much interest in. But check out what I got for $14.99 plus tax. This is an Audio Source Model EQ8 Series 2. So this is a stereo graphic equalizer and spectrum analyzer in the middle there. So if I power this on, you can see we've got a bunch of lighted knobs, which is super cool. I've got a stereo input here that I have, I'm playing out of an iPad over here with Spotify on it. And what I'll do is I'll play some Bartle beats. And what you should be able to hear is I'm going to be able to boost certain frequencies or cut certain frequencies. So that took the bass out of it. That pushes the highs. I'm not running stereo right now, so I'm kind of ignoring that side there. But it's cool, you get to see the frequencies that are being pushed. So I had some peaking there and some of the mids to trebles. All right, super cool. And one of the things about this is when I got it, it was missing one of these knobs, and one of the knobs didn't have its little LED working. So I went to take a look at it, and I looked in one of the knobs. You can see this very bright one here, or sliders rather. Let me get that to focus there. The reason this was fixable is that the knobs are LEDs. They have a little plastic cover and a little light pipe, a little lens, and then it's literally a straight up 5mm LED, or maybe a 3mm LED, with contacts inside of the fader slider handle. So since it was missing one, I'll leave that one in there. I've got it jammed in there and heat shrink to it. I just took an existing LED I had. I should have put a little plastic in front of it to dim it a little bit. But I just put some heat shrink over it once I had that inserted, and now I have knobs on all of them. And one of these was just loose over here. I think it's this one here that's maybe the contacts need to be cleaned inside of it. So this is my little find here. It's got a little bend in the cover, and that's about it. That's the only other thing wrong with it. Probably got dropped at some point. So I'm going to bend that back. There, you can see that just needs to get set on a 2x4 and hit with a rubber mallet. I think it's going to be my approach there. We'll see how that works. And then inside, I don't know. I haven't looked up any of these chips, but this is what we have inside. Giant transformer. Not giant, but big transformer here, a whole bunch of audio I/O. The whole switch scenario here is interesting. It's a really big board. Let me zoom in. A really big board with mechanical extensions to the switches. So these are little toggle switches, spring-loaded toggle switches that are really far back from here, and they have quite a few contacts on them. So I think these are able to do switching of a bunch of things, which may be how we're switching some of the outputs to just monitor or not run it before or after the EQ, pass the EQ through. This sends it to a different output. And then this has a different set of inputs, which they called video, but it's really for your, let me focus on that a little better. They meant this for like a cassette player and a VCR, it seems from the manual what they had in mind. So this could be labeled anything, but it's just two different RCA inputs, either this set or this set. So anyway, kind of cool, and neat little matrix LED board there. You can see it's just got these tiny surface mount LEDs, I believe they are, that light up with the spectrum analyzer. You can see it there again. So cool find. So I recommend check out your local thrift stores if you can. It's a form of ecologically friendly consumerism, I guess, and pretty cheap in a lot of cases. So that's my little thrift store find of the week. And I think these go for maybe $40 realistically on Reverb or something like that. So it's not like it's a priceless artifact. DJ Devon, why would you intentionally design such long buttons? So weird. Yeah, you got me. If anyone has insights on that, I'm curious. All right, so let's pull this apart. We'll see if I find a home for this. I may just set it right underneath my Euro rack. It may fit under one tier of my Euro rack, and then send my audio out off of my mixer to this, so I can have a little extra EQ, which would be kind of fun. But for now, let's set this right here on top of a TV. And let's see if I got. There we go. Switch those cameras around. Next thing is the project I'm working on. So you may have seen me demo this last night on Ask an Engineer, or rather on Show and Tell. I am in process of building this right here. This, you can see my fritzing diagram of my wiring. I have just wired up the display on my little Walkperson, as I'm calling it. So it's an MP3 Walkperson, and I'm going to be doing display stuff, which I haven't done yet, but I've got MP3 playback working, and the thing that is new that I'm excited about is I've got the MP3s playing right off of SD card. So let's see, I could probably grab a cable here for sending out that audio. So let me first show you what I got. I know it's a bit of a mess of wires right now. And let me switch that large view. Oh, I'm sorry, this is a bit shaky. There we go. So what we have here, Feather M4. I am sending out digital audio. It's kind of the best possible audio quality that we can get. Digital audio out to an I2S amplifier. So this is I2S decoding, turns it into an analog signal, amplifies it. And I've sort of discovered some things along the way in building this. So first of all, on our little I2S amp, which I'll go over to the computer and show some close-ups of this. We have a gain pin, which you can leave alone, and you get, I think, a plus 9 dB amplification. You can then use different combinations of resistors or wires shorted to the voltage input, and that will change the setting. It's just sort of a startup thing. You can't really do this actively, and it's just a few increments. You can't use a potentiometer with it. But I've put a 100K ohm resistor from gain to the voltage in on that, and that gives me, just drops it down to 3 dB, which makes this work pretty well for headphones and line out. So you can see, instead of running to a speaker, which is kind of what this one is designed for, I wanted to use it as a headphone amp, albeit it's a mono one. There are ways to run 2 of these, but that then really only works for speakers. So you can use 2 of these for stereo off of the same set of pins, in fact. You can just tell each one who's being left or right, or a mix. But that won't work well with headphones because of the type of, this isn't really a ground, this is more like an AC, which doesn't work that well for left-right and sleeve TRS jacks for a set of headphones or a powered speaker. So other thing I found out is that this amp really wants 5 volts. I'm not sure exactly why, and Lady 8 is looking into this because it's actually rated for 2.5 to 6 or something like that. input voltage on this little Max 98357A chip is this one here. For some reason, it's really noisy when I have 3 volts, no matter the 3-volt source. I've tried a bunch of them. When I give it 5 volts, super clean, really clean sound, kind of the cleanest sound I've gotten off of a microcontroller with an amp. And so to do that right now, I'm using this little, we call it the mini boost, and that boosts whatever you give it up to a nice clean 5 volts. So I'm giving it 3.3 off of the battery pin. So this will run off a battery. In fact, if I take off the jumper of the enable pin to ground, this is running now. I'm going to turn that off again for now. And then the other connections I have are, I'm running a set of transport controls. So next song, previous song, play, and stop. And maybe I'll adjust what those do, but this is just a nice set of Neo key mechanical key switches. I got some clicky Kale box whites, and that is running over I2C. And so I2C, I'm using this great little, since my Feather M4 board here does not have a Stemma QT/Quick port, I'm using one of these little SparkFun breakouts that has 4 header pins that go into your breadboard or your perf board or your circuit board, and gives you 2 of these Stemma QT cables. I'm going to be adding a rotary encoder breakout also on I2C, so it'll be plugged into this, and that'll give me volume control because I'm using the CircuitPython audio mixer to be able to adjust the sound level. And maybe the push encoder of it to do other menu-y kinds of things. And then the sort of new cool part is I've got this display here which currently does nothing. I think the backlight lights up. Other than I am using the SD card on the back of it. So this is super cool. I have one of our, you know, the Adafruit store sells these really tiny SD cards. This one has 128 megs on it. We even sell a 64 meg one. And these are kind of perfect. They're cheap and they're perfect for use as essentially a mixtape. So I want to use this little Walkperson as a sort of a mixtape thing. Then I'm going to want to be able to have different cassettes of SD cards. And I might even do some cute little tiny cassette graphics for these. So this makes it really simple. With whatever cassette I have in, those are the songs I can play. I'm going to display them. Eventually I'm going to rotate the display sideways, and I'll put, I think, a cassette tape icon, maybe with some animation of it moving, and the name of the song and the mixtape kind of as tape labels. That's the goal here. And but I'm really excited because the Feather M4 is a great board for doing this, except it doesn't have much memory. It has 2 megs of space on it, so you can't really get that many songs on there of any quality or length. It helps that I'm doing mono, but now with the SD cards I could do bigger files and stereo files. So let me do a little quick demo of this. So I'm going to plug in an audio cable. I'll plug this into my little amp here. And so this is very much just a mono thing at the moment. But what I've been testing it with is a nice little set of headphones, which it works great using headphones. These ones actually, these are the ones they sell in the Adafruit store. I kind of want to get old-fashioned Walkman style ones, but these ones in the Adafruit store are great because they have a analog potentiometer, really tiny slide pod on there. So you can do your own volume control, which is great since I don't have volume happening yet on here. Oh, Z says, use a microcassette case to hold them. I love that. That's a really cute idea. I'll look at that. I have, I think, all of 3 microcassettes here. So let me turn my amplifier on here, and I'm going to turn on the board. And now I can play. Be nice once I have stuff on the screen telling me the state of things. Okay, so this is another Bartle Beats song off of the album Frequency, so we have no worries of copyright strikes, which is great. So I can hit stop. I can use the next, and that's going to play the next song. I think I have 4 songs on the SD card right now. I can go back, previous one there, or loop all the way back around. So that's the 4th or 5th, whatever it is, song on there. And stop. So that's the basic function of it right now. Over in the chat, thank you, C. Grover. C. Grover reminded me that he's made a really cool PCB that is a stemma backpack for a feather board. So it can sandwich right on or under, I guess, a feather, and it gives you both a stemma cable, full size, and a stemma QT cable, small size. Very cool. So let's take a look now at how some of this is working in code, as well as some of the parts. I'm gonna unplug this. Let me shut it down. I'm also going to add instead of this wire for enable, I'm going to add a on-off switch to it, I think, just to give us a neat way to turn the thing on and off and save battery. But again, nice project to use Feather on, because it means that we can do battery and battery charging just by leaving the same USB port available that we want to have available for any type of code adjustments. And I'm also going to come up with a case that gives us this essentially this will be our interface, the cassette display there, and the transport buttons, and ideally leave the case right up open to the edge there. There's a spring-loaded SD card, so we should be able to get new cassettes in there with some care. There we go. Without needing to extend that. If we do, I have a little PCB that Adafruit sells that's an extender for an SD card slot that adds about 3 inches, 2 inches or so of extension off the edge of the board. So let's see. Yeah, let me bring this over and we'll plug it in and check it out. All right. And I'm going to bring up how about this view right here will work well, actually. Zoom out a little bit. Yeah, I think Lamore has said if and when M4 chips come back into the world, there may be don't ask questions about it, but there may be a new spin of the Feather M4 that'll have USB-C and a stemma QT port on it. I'm not sure about other changes, but those would be welcome. Okay, so let me jump over to Atom, and let's open up code.py on this board. Is this up and running? Let me take the enable cable off of there. You know what I may do also? I don't know do I have an adapter? I may show you the contents of the SD card just so you can see how that's laid out. Currently, I just have them at the root level of the card, and I am not using directories or any kind of like text file or anything like that. It might be neat to use text files to sort separate song lists, but really in the spirit of it being like a cassette, I kind of want to stay away from that and just have you pull out a SD card and put the new one in. So if you take a look here, first of all, I've got some SPI set up for the SD card, and I'll be writing a guide about this. One thing that tripped me up is when I looked at an SD card guide that we have, it mentioned setting up your card, your chip select pin. And so that usually looks like this. CS equals, and then the pin that you've connected from chip select to your microcontroller. Well, I did that, and it kept saying to me, there's no SD card, we're not finding one. And after a while, I was really looking closely at this board here, and I realized there's both a chip select pin and an SDCS. That's the SD card chip select. So I was using the display chip select because they're both over SPI by accident, so it was confused. So SDCS is what we actually have to connect in this case. And so here, I mean, I'm naming it that way just to prevent confusion. This could be named CS, but more to the point, I was plugged into the wrong pin on this display. So be careful about that. So we're setting up SPI for the SD card, just like the SD card breakout. It works the same. And then we're setting up the file system. It's a FAT file system, and we're mounting it. And we're mounting the drive, essentially called SD. I haven't done much of this stuff in CircuitPython before, and it works so well. It works really easily. It's really straightforward. I was pleased at how quickly I was able to go from having a couple of tiny test files on the Feather itself to putting full big song MP3s on the SD card and running them right off of there. Next, I'm setting up my Neo key, which is what I'm using here for transport control. I'm setting that up over I2C, setting some pixel colors and some key states. And then MP3s, if you look at how I was doing it initially, that's this right here. I'm going to zoom in. Nope, not like that, I'm not. There we go. So initially I had a folder on the Feather called MP3. It's actually still there. And I had these two MP3s here that are tiny. Then when I switched to using the SD card, all you have to do, since I mounted it up here, where did we go? I mounted it as /SD. You can mount that, I think, as anything you want, but I've mounted it as /SD. Now I'm able to just start pulling that list off of the SD card, pulling MP3s off the SD card. And then the next step for this, of course, and you'll see this in some of the Adafruit projects that do MP3 stuff. There's a really great JEP player from Jeff Epler. Foamy Guy has the Winamp style PyPortal player. Any of the older Adafruit Music Maker Featherwing or Music Maker Shield projects that are done in Arduino typically will have this moment where they just check the file system that you're using, so in my case the SD card, and grab the names of everything there, which is going to include a whole bunch of junk, and then throw away the junk and just keep the stuff that's got a nice name that starts not with a dot or an underscore and ends in .mp3. And so this is a version of that I was about to dive into when Toddbot, our good friend Todd Kurt, said, hey, here's a very simple snippet of code that'll do just that. So thank you, saved me an hour, I'm sure. So if you look at this bit right here, I'm creating a list called MP3s, and then in this loop, for each file name in this OS, there's that OS, operating system library again, OS list dir, and then the name of the directory, which is our SD card. If the file name ends in MP3 and doesn't start in a dot, then that's the list we're going to grab. And I'm appending each of those good names, not all that junk, to this list. So actually, let me connect to this board. Hopefully that's the right board. Let me unplug my camera switcher. Okay, I think it was. Reload here. So you can see when it boots, it prints out SD file name and so on. If I take this and run that, let's see. Do I have an easy way to do this? I don't. I don't want to do that. But if I ran through all of those before doing this, you would see a whole bunch of files that have crummy names. Let's see. Can I do? Let me see if I can do it this way. List index out of range. Why? For file name and OS list. Okay, I'm not going to mess with that. But point being, we now have this list. Let me resave that. that is the good, clean names. This is also why I got into this whole sorting thing. So my next thing I did was sort these alphabetically. So you can see when I print out that list of what's on the file system, it may be date-based. It may be the oldest to the newest that it printed. I'm actually not quite sure what it sorted it by. But I want to be able to put my songs in order. And so what I think I plan to do on the SD card is simply name them with 0, 1 through 12 or whatever, if I have 12 songs on the tape. And if I do this MP3 sort, it takes this list that I'd already created and it recreates the list, this time alphanumerically. So a 0, 1 should happen before a 0, 2 and so on. So this is the proper list right here. This was a short-lived moment, if I jump ahead, of me calling it the walk muffin with a lowercase u and a lowercase n. Now this is going to be the walk person. Like that. There we go. Walking person. Let's see. So after I create the list and sort that properly, and here I'm just printing it for fun, so we can see the list there. Now I'm setting up a variable called track number, and this is what's going to keep track of which one we're on. The first one is indexed to 0, so it'll be the first track. The name of the song is my list of MP3s and the first entry in that sorted list, so the track number 0. Then we set up the audio bus. So this is using, this is using I2S out. So that's that I2S output, set of 3 pins, I think it is, for clock, a couple for clock and data. And that is, like I said, capable of sending stereo. It sends the left, right, the data on the left and the right pins, sort of interleaved, I think. Sorry, on the data pin, interleaved with a clock that says, right now we're sending a left bit, now we're sending a right bit, and back and forth. Then you can decide to use the thing in left mode, right mode, or mixed mode, I think are the choices there for how it actually outputs over its single output. So I2S output, and then we set a set of pins. So we're telling it the bit clock pin, the word select pin, and the data pin. And actually, Lamora was talking about this last night on Ask an Engineer because she was talking about a couple of chips, maybe this one and another one, or a revision of this chip that's on here. What is this one? The Max 98357A. And unlike some I2S chips, this one does not require what's usually called the master clock. This one just doesn't need that, and I didn't catch why. I was trying to look and see, can I use one of these, which is the Teensy audio breakout adapter, or Teensy audio adapter. This is made for Teensy. It could probably be wired to run on other things. And it's got a nice little headphone out on there, and it has an SD card on it, so it covers a lot of the bases. But this one will not, as far as I can tell, work without having a master clock pin, and I don't think we have that worked out in our libraries. So for now, at least, that one's not going to work for me. So then I set up my MP3 stream object as an audio MP3, so I have that library imported, MP3 decoder, and then I open the song, which was this MP3's list item 0, in, I think that's raw mode, raw binary mode. And then I create a mixer object. So you can play MP3s without it, but by creating the mixer object, now we'll be able to adjust volume and do other fun tricks. You can play multiple streams, which would make it kind of tempting to crossfade. So when you get to the end of a song, somehow, I don't know if it's really possible, but somehow if you could know that you're getting to the end of a song, then you could start the next song a little early by having it be a second voice in the mixer and then do a crossfade between them, which would be kind of cool. But I'm not sure about that part of being able to know where you are in the track. Maybe it's possible. Let me know in the chat if you've ever run into something like that. And hold on, I gotta move my window out of the way. See, so when I set up this mixer, I'm just setting a voice count of 1. You could do multiples of those, like the breakbeat breadboard project used, I think, 8. I had 8 voices playing at once. Setting the sample rate to 22 kilohertz. Channel count is 1, and that means that I'm reading mono files. So you could have this be stereo files or mono files, but I'm choosing, like I've said, for various reasons to do this mono. Bits per sample, 16. Samples signed is true. I'm setting my level really low, so you can see 0.05, and that was plenty loud. You could hear those when they're playing. And then finally, I set the audio to play the mixer object. And I'm also setting this play state to false. So this means nothing is playing. The machine doesn't think that it should be playing anything when we start. So what I do next is I say, if the play state is true, well, it's not, so let's skip that. So the play state isn't true when we start. So now we jump down to checking our neo keys. And I'm just looking at all the keys. And if one is getting pressed and it wasn't currently pressed, so this is kind of a debouncing, then I'll set the key state to true. And I'll light it up for whatever color it is. And right now, this needs to be optimized, but I essentially say if the key is key 0, that's the reverse key. So it will change my track number by decrementing it, subtract 1, modulo however many MP3s there are, so we can loop back to song 4 or whatever when we go all the way through the list. Same going forward. Then I change what the MP3 stream is playing. I open up the new song. I am not looping it, so it'll just play it once. And I've set this play state to true. The reason this matters, and this is the way all of them work except for stop. Stop just stops it, sets the play state to false. But let's look at the play button, which is this white one here. This is button number 2, 0, 1, 2. I print play. I'm playing a song. And I've set the play state to true. When this finishes, so let me plug in so we can hear some audio on this. And I was testing this with some little 5-second long songs, because otherwise I'm going to wait 2 minutes for this to get to the end. But let's turn on a little speaker I have here. Okay, so you can hear, right? Okay, so it's playing this little song. I'm going to talk while it finishes, and you almost don't need to hear it, but what you should see when it finishes up is that this is going to move on to the next song. And the way that does that is if we look at this first thing that I skipped, this loop, if play state is true. So the play state is true currently because it's playing, and I said so. I pressed a button and made it say that play state is true. We can check if the mixer is playing or not. So the mixer playing is true while the song is on, and it's false when the song stops. So that's our easiest way to just check and see, is this thing running? So when that song ends, this is going to become true. This is going to become false. The mixer is not playing. So then I'm printing for myself next song, increment the track number, do the same exact thing we did with any of those buttons. So this means it's just going to play forever. Now, in true cassette fashion, it might be fun to have that end on the last one, so do another check to see which number we're on, and if it's the length of the list, then we stop on that one. Also fun, since we have mixer, to add some rewind sounds, forward sounds, other things like that would be fun and possible with this. Let's see, it sounds like this song is nearing its end. We'll see how long that outro is there. The fabulous Bartle beats. Oh, it's got legs. All right. I'm going to check the Discord chat just in case anyone knows of a way to ask a file if it's nearing the end. No word yet. All right. Come on, song, you can do it. Actually, you know what? Let me show you how I'm doing this as I develop, because I still have those short songs on the Feather. Even though I have the SD card in there, we can use those instead. So check this out here. I'll hit stop. Oh wait, this is about to end, I bet. No, it's not. The song doesn't want to end. Okay, I'm going to end it. So here I can do something real simple. I'm going to make my MP3s list just be the Feather itself. So if you don't go and mount some other file system, this should just pull songs off of the Feather. And I have an MP3 folder on the Feather. Okay, so I'm going to hit play. Now watch the text output. It's going to end in like a second. There you go. Next song. About 5 seconds of Daisy. Now it should loop back around. Next song. Okay. So that's just a tip I have there for testing this. You don't want an actual song length song in there. All right, so if I reload this, we should be back to the SD card. And I really should put like some debug flag that flips between these. That would be neater than just commenting stuff out. But this code is pretty short, so it's not too much to keep track of. Let's see. So Dexter says position of a playing MP3. I don't think there's a way. So I'm curious if I could do extra work, like create metadata before I put the SD card in, that run a program that grabs the length of the MP3 and includes that in a little piece of like side text with the playlist or something, and then we can do it based on that. Sounds complicated though. Blitz City DIY says could maybe do something with the samples decoded. Oh, interesting. All right. We'll keep those suggestions coming. I will try some stuff because I think that'll be really fun to be able to know the length of these. Could even do graphics based on that, like how big the reel is of cassette that's shrinking in the animation, if I get that ambitious with it. But I think that's what I've got to show. So let me know if you have any other questions about how that's working so far and where it's headed. Let's see, what else is going on in the chat? Yeah, Todd says you could store the length in the file name. That's way simpler than what I was thinking of, having a little sidecar file there. Track 1, 4 minutes, 33 seconds, .mp3. I like that. Let's see. Oh, one other thing. I saw that, so this was inspired by project. I'm not going to go grab it right now. Inspired by project I've talked about before, that was an MP3 player that looked like an old desktop cassette tape recorder. Beautiful, great project. That was part of the inspiration for this. That one included some code to store the position of where you are in the MP3 when you stop, which means you can pick back up again without just restarting it. They were using it as an audiobook. They wanted to be able to do audiobooks. It's really important in your 17-hour file to be able to save that bookmark or that position. So I'd be curious if that's straightforward to do. It's not that important for this project, and I'm not really trying to do fast forwarding partway into songs or anything like that, although obviously that could be a possibility as well. But let me know if anyone has ideas about some of these more advanced MP3 topics, and I'll take a look at Jepler and Foamy Guy's code and talk to them a bit to see if they have any suggestions. They made full-blown, like really sophisticated MP3 players, so mine is quite simple by comparison. All right, I think that is going to do it. Have I missed anything? It feels like the show. Thanks everyone for stopping by. I appreciate you hanging out and hanging out in the chat as well. Stop by tomorrow, Friday, for a deep dive with Foamy Guy. We'll be back on Tuesday with my NextJP's product pick of the week, and then Wednesday 3D Hangouts, show and tell, ask an engineer, another one of these, another one of those, and on it goes. So we couldn't do it without you. Thank you everyone for stopping by, hanging out, supporting us, and that's going to do it. So I will see you next time. Bye-bye.